Well, hello, calculus group. Today I'm obviously away, so I would like for us to still get lots done. We are going to review what we'd already talked about at the start of section 6.2, and then I'll show you a few more examples. You'll notice also that the handouts are before you, so you can fill in information as needed as the examples are being completed. And if at any point during the lesson you need to just pause the video to write something down, just go ahead and shout that out so that everyone has that opportunity. So a couple reminders for you. First of all, in calculus, the letter S represents distance because the D refers to the derivative, so we don't want to find confusion there. The first expression in most of these questions will involve a distance, at least in this section. In fact, they all will. And so if we want to find the distance at any point, we simply replace the time value. But if we want to find the speed, that is the first derivative of the distance. So the first derivative is the speed at any time t, and in this case that would be 3t squared plus 6t. So if I want to find the velocity at 5 seconds, as in with part B, I would find the speed at 5 seconds, replace the t with 5, and then find my answer. So 3 times 25 is 75, plus 30 is 105. And this question is dealing with centimeters and seconds, so that would be measured in centimeters. So original expression is distance. Derivative is speed. If you want to find average speed, you're going to need to find the change in the distance over the change in time. So we would need to find, I guess I should use the letter S there, shouldn't I? So the change in distance would be as such. So we're going to find the value of the distance at 5, take away the value of the distance at 1, and then the change in time would be 5, take away 1, which is 4. And we've done that before, so I'm not going to bother doing that now. Question D asks us to find at what time, no, that's not true. It says where is the ball when its speed is exactly 72 centimeters per second. So the first thing I'm going to need to figure out is at what time that happens. So I'm going to use the first derivative and make it equal to that speed. So 3t squared plus 6t equals 72. To solve for t here, I'm first going to divide by 3, and at the same time move the 72 over to this side, so I'll get 3 goes into 72 twice, 24. And now I'm going to factor this using my zero product property to find the answer. And I changed my t to an x, forgive me for that. And we'll get two answers here, that the time could be 4 seconds, or the time could be -6 seconds. And as you can probably think to yourself right now, we need to reject that answer. You can't go back in time. So that time is 4 seconds. But we didn't answer the question yet. We're asked to find where is the ball. So in order to finish this question, you would need to find the distance at 4 seconds by replacing 4 in the original expression. So you'd have 4 cubed plus 3 times 4 squared. So 4 cubed plus 3 times 4 squared. That's 64 plus 48, I believe. So that's 112, and that again will be measured in centimeters. To find the acceleration, that's the change in the speed with respect to time. How fast are you getting faster? How fast are you getting slower? And that is actually your second derivative. So your second derivative is the same as the first derivative of your speed, or the rate of change of the speed, which is your acceleration. All those three things mean the same. And so when we look at our expression for speed, which was 3t squared plus 6t, our second derivative would be 6t plus 6. So if I want to now find the acceleration at time 1, I would write it as such that I'm finding the acceleration when the time is 1. That's 6 times 1 plus 6, and the answer is 12 centimeters squared per second. So with every second that goes by, the speed is increasing by 12 centimeters per second. What is the velocity of the ball when its acceleration is 54? So very similar question to what we did before. This time we're going to use our acceleration and make it equal to our acceleration expression to find the time when that happens. So if the acceleration is 54, when does that happen? So we take away 6 and divide by 6. I believe we're going to get 48 divided by 6 is 6 seconds is when that happens. So to find the speed now, we find the speed at 6 seconds. So we go back to our expression for speed, which is still 3t squared plus 6t. So it'll be 3 times 6 squared plus 6 times 6. So 3 times 36 is 108 plus 36 is 144, and the unit for that would be centimeters per second. To find your average acceleration, that would be the change in speed over the change in time. So you'd need to find the speed at 5 seconds, take away the speed at 1, and then divide by 5, take away 1, which is 4 seconds, and then you'd have your answer. So that's one example. A second example involves throwing a rock up into the air. So this rock is thrown upwards and then it's going to fall. So we dealt with these type of questions in Physics 30. To find the initial height of the rock, we're going to need to replace time with 0. So h of 0 is 5. It's measured in meters. So that will be 5 meters. So this rock is quite high up. 5 meters is the height of the house. To find the velocity of the rock after 2 seconds, we find the derivative, which is the speed at any time t, which would be negative 10t plus 40. And now we're going to find the speed at 2 seconds, so we replace the time with 2, and we'll get our answer. 40 take away 20 is 20, and that's in meters per second. Now, question C is a reference to the vertex. When does the rock reach its maximum height? Now, in previous math classes, we knew how to find the vertex a number of different ways, completing the square, partial factoring, using our zeros. Now we want to use the derivative. The derivative, or the expression for velocity, will allow us to find this answer because at that moment, the slope of the tangent line is 0. So if our velocity expression is a plus 40, yes. When this equals 0, we will find what we call our critical numbers, which will often be at a relative max or min point. We already know the shape of this graph. It's a parabola that's going to go up and then come down. So we already know that we have a relative max point because it will go from increasing to have a slope of 0 to being negative. We just need to find that time. And so if we solve this expression now and subtract 40 and then divide by negative 10, we'll find that that happens at 4 seconds. Now to figure out how high that is, we have to go back to our original expression and find the height at 4. So we replace 4 in the expression negative 5 times 4 squared plus 40 times the time, and then the constant value was 5. So we get negative 5 times 16 is negative 80, plus 4 times 4, that's 160 plus 5, and we'll get our answer as being 85 meters, quite high. Now to find when this rock hits the ground, we're going to need to find the time when the height is 0. Not replacing the time with 0, but making the actual height 0. So if I make the height 0 and I make it equal to our original expression for height, if I divide both sides by minus 5, I don't know any numbers that multiply to minus 1 and add to negative 8. In order to solve this, you're going to have to use the quadratic formula. and then round your answer to 1 decimal place. So the quadratic formula is still up on the board there for you to use to do that type of question. Now, in order to answer question E, we would need to know the answer to question D. So in order for us to find the velocity at any time, it's negative 10 times t plus 40. We would need to find the time when it hits the ground and then replace that t with that time value. Just make sure when you do the quadratic formula that your answer makes sense. You'll usually get two answers. In this case, one will probably be a positive time and another will be a negative time. We already know that this happens at 4 seconds, so it has to be sometime past 4 seconds. So just pick the answer that makes the most sense or the most logical sense for the context of this problem. One thing I wanted to mention here, it's not asked to do it, but if we find the second derivative, which is the acceleration, notice you get negative 10 meters per second squared, which should kind of ring a bell for you because in physics we dealt with negative 9.8 meters per second squared over and over and over again. Negative 10 is just an estimation of that acceleration due to gravity. Last one. Suppose a bee flies along the x-axis or along a horizontal or straight path so that its position is given by this function. So we're not going to assume left and right motion, just kind of forward and back motion, otherwise things get too complicated. So let's go ahead and deal with this question. What is the place where the bee is at 3 seconds? So we find the value at 3, get the answer. You have no problem with that. Question B, you're probably not going to have a problem with as well, because to find the speed, we simply find the first derivative, which is 6t squared minus 42t plus 60. And then we replace the time with 3. Very manageable. We could also do the same thing for part C. We're going to find the speed at 6. Get an answer. But question D is a little bit new, or at least you have to apply what you know. When we look at the derivative, which is 6t squared minus 42t plus 60, and I factor it, and then finish that job off. And then if I do a sign analysis of these factors, now I'm not going to worry about the 6 because that's always positive and never 0. We have zeros at 2 and at 5. This tells me that the graph of the bee, if I were to start at 0, I don't know where the 0 would be. I could figure it out, but not for now. We have zeros at 2 and at 5. And basically we're told that it's increasing to 2. Sorry, that's incorrect. I'll just draw it in red here. Increasing to 2, decreasing, and then increasing. So some sort of path like such. The question is, when is the bee moving to the right? Sorry, this should have been a plus sign right there. Or in other words, when is the motion positive for the speed? And when we talk about speed being positive or negative, does that mean we're looking for the increasing and decreasing intervals of the derivative? Or does it mean that we're looking for it's above or below the x-axis? So that's something for you to think about. How we determine when the bee is moving to the right. And I would say that's where the speed is positive, that is when the bee is moving to the right. And when the speed is negative, it's going to be moving to the left. So the answer for this question would be from 0 to 2 seconds, because the bee starts moving at 0. So it's going forward or to the right, and then it goes backwards for a time, and then it goes forwards again. So forwards, then backwards, then forwards. So that answers part E. Now question F says, how could you determine how far the bee went? So again, from 0 to 2, we have the bee going forwards. From 2 to 5, it's going backwards. And then from 5 to 6, which is the boundary here, we're going forwards again. So what we need to do is find, well, how far did the bee go during the first 2 seconds? and then add to it, well, how far did the bee go during the seconds from 5 back to 2, so that's 3 seconds, and then how far did the bee go during the last portion. Sorry, this is not correct, is it? No, that's right. So that would be from 5 to 6 seconds, and then total those up. So that requires us to go back to the original expression to find the distance over each of those. And even though the bee is going backwards, we still need to find the distance because it's positive. Now, something that's wrong here is in my head I'm thinking of these 2 and 5 being the time intervals, but that's just simply the place where the bee changes direction. So I'm wondering if I'm correct on that. I might have to come back to that, or maybe your teacher can help you with that. I'm not 100% sure on that one in terms of the number of values we're going to get. Nevertheless, you started your assignment here last time. If you have trouble with a question like that, we'll talk about it next class. I'm just having a little bit of a brain fart at the moment. So you got this class to work on it, and the next class as well. And my expectation is that you will master it and feel very confident to ask questions about it tomorrow, and then we'll go on to the next portion of your unit next class. So that's it. Hope things go well for you, and please let me know how it goes.